Our third application for rational functions is distance, rate, and time. Now, somewhere along the road, you've learned that distance is equal to rate times time. Get it? Along the road? Yeah, that's good. All right, so distance, meaning how far you're traveling. Rate is your rate of speed. And time is how long you're traveling at that rate of speed, right? I mean, you can imagine it with cars pretty easily, but it works for all sorts of things, projectiles and various other things. All right, so we have a student at Seattle Central Community College plans to drive from Seattle, Washington to Eugene, Oregon. The speed limit is 70 miles per hour in Washington and 65 miles per hour in Oregon. She will drive 164 miles in Washington and then 121 miles in Oregon. Now, if the student drives steadily at the posted speed limits, compute the driving time. So time is what we're interested in this problem, not distance. So I'm going to use my function, rate times time equals distance. So here, distance equals rate times time. I'm going to solve it for time because time is what I'm actually caring about here. So I'm going to divide both sides by the rate, which leads us to the corollary to distance is equal to rate times time, which is that time is equal to distance divided by rate. Right? If you want to know how long it's going to take you to drive somewhere, then you take how far it is and divide it by how fast you're going. Right? Okay, so we'll use that idea for this person, this student. So her time total is going to be equal to, now, but she's driving in two different areas. So I need her driving distance in Washington divided by how fast she's going in Washington, plus her distance in Oregon divided by her rate for Oregon. All right, now her distance was 164, and she's going to go 70 miles per hour in Washington, plus 121 miles for Oregon, and she can only go 65 if she goes the posted speed limits. So I just need to find what this is. So I will grab a calculator, and I'm going to hit alpha F1. That's what I did before. Right, so alpha F1, and I'm going to pick number 1, 164, arrow down, 70, plus, and then I'm going to hit alpha F1 again, and hit number 1, and it's 121, arrow down, 65, enter. So you get 1913 over 455, which isn't that helpful to us because it's a fractional answer, so I don't really want that, but it gave me what I can type in and get the decimal approximation. Of course, if you have an old calculator, you have to type 164 over 70 plus 121 over 65. That'll work as well. As a matter of fact, in this case, that one's faster. It just doesn't look quite as pretty. All right, so 4.2. And then since this is miles per hour for her rate, then it's got to be hours, right? You can't make this trip in minutes. It's a long trip. It's a very pretty trip, but long. All right, we're done with that one. Now, let's suppose that this driver exceeds the speed limit. So we found her time if she goes exactly the speed limit. So let's find her equation if she doesn't go the speed limit. If she goes faster by a miles per hour. So it's going to become a new function, t of a. And then instead of going 70, she's going 70 plus a, and then 65 plus a. And there we go. Because her distances haven't changed. I mean, Oregon and Washington aren't changing just because she drives faster. So there's the overall answer. Which really means this function up here, when you found this time, what you were finding was t of 0. If she goes exactly the speed limit, right, that's what you were finding. In other words, she is not over the speed limit by anything, right? All right, now find t of 5, and what does it mean? All right, so let's go find it. So t of 5 means you're going to put 5 in for a. So 5 right here and 5 right here, which means it's 164 over 75 plus 121 over 70. And then we would go find that. Again with the calculator. So we don't have to do the pretty way if we don't want to. So we can take 164 divided by 75 plus 121 divided by 70, enter, and 3.92. And again, it's hours. Always got to give units to story problems like this. There we go. So what does that mean? That means that if the student drives 5 miles per hour over the speed limit in both Washington and Oregon, she will make the trip in 3.92 hours. And there we go. Now we're going to find A so that T of A is equal to 3.5 by calculator and figure out what that means. All right, well, we have our function right here for part B for what T of A is. And what I want to do is I want to set it equal to 3.5 with my calculator. So I'm going to go grab my calculator. I'm going to go to y equals. I'm going to clear out this old function in here. And this is a time where I think it's helpful, if you can, to write it in the old format, or the new format, excuse me. So you'd say 164, arrow down, what would it be? 70 plus x. Because you don't get to use A. And then use your right arrow to get out of there. And then say plus, and then set up another one, alpha F1, pick number 1, 121, arrow down, 65 plus x, right? There's our function. Now, if you have an old school calculator and you can't do that, let me type it up down here what it would look like. 164 divided by parentheses, 70 plus x. Close that parentheses. You got to make sure you open and close that parentheses. Then plus 121 divided by parentheses again, 65 plus x. Close that parentheses. It's not nearly as pretty, and it's more easy to make a mistake, but that's it. That's the function. Okay. I'm going to clear it out, though, because I don't need it. So clear. 3.5 is what I am actually interested in, because they wanted to know when it was equal to 3.5. And then I'm going to figure out what that means in a minute. So I have it in my calculator at 3.5. Now I want to make a window that makes sense. So let's go to the window and look. X was what for our particular function? X was our letter A. That's our independent variable, which was how much you're exceeding the speed limit by. Well, I doubt she's going over by like 100 or 50 or whatever. So let's go 0 to, I don't know, how about 25? Maybe she's going 25 miles per hour over the speed limit. That would be a lot. X scale is 5 is fine. Y is the time, right? How long it's taking her to get there. Well, we know that if at 0 it's going to be 4.2 and at 5 it's going to be 3.92 because the faster she goes, the less time it's going to take. So we don't know 0 to 100. We need to 0 to like 5. And then tick mark's worth 1. Let's graph it. So there's the function. The faster she goes, the less time it's going to take. Here's her time function. And then there's 3.5 right there. So you hit second, calc, number 5, enter, 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 and there it finds it. 13.627. There, I've copied it, and I'm going to paste it in over here. Because you would, of course, draw a picture on your paper to verify that you did this by calculator, and you would label it, just like the computer capture here has labeled it. All right, now what does it mean? In order to make the trip from Seattle to Eugene in 3.5 hours, the student would need to go 13.27 miles per hour over the speed limit in both states. Done. All right, last but not least, we're going to do this by hand as well, just for the sake of it. So let me type that up. It would be 164 over 70 plus A plus 121 over 65 plus A equals 3.5. All right, how do we do this? Well, we need to multiply everything by the LCD, which would be these two factors multiplied. So what I'm going to do is I'm going to put the whole thing, actually, let me write it all again just so you have all the work. So I'm going to take the whole thing, I'm going to multiply everything by the two factors, 70 plus A and 65 plus A. Matter of fact, if you like, what you can do is you can write one of those for each one of these. So hold on. It's a little bit messy, but it'll show what you're doing, right? So you're going to take this and you're going to put it over 1 and you're going to multiply it by every single one of these. So it goes here on the first term, here in the middle term, here on the last term. Now it looks really horrible, but remember your reason for doing it is it makes all the fractions disappear because 70 plus A, numerator and denominator, disappears. So you're left with 164 times 65 plus A there. Over on this one, the 65 plus A is going to go away, both here and here. And then in the last one, nothing disappears. So we'll have to figure that out in a minute. Okay, so we have 164 times 65 plus A. And then plus 121 times 70 plus A. And then we have this whole thing, 3.5. So equals 3.5 times 70 plus A times 65 plus A, because nothing went away on that side. Now we have no more fractions though, so that's good. Okay, so now we're going to distribute 164 times 65 is 10660. All right, so 10660 plus 164A plus, oh, I need 121 times 70. 121 times 70 is 8470. So plus 8470 plus 121A equals 3.5, and then we're going to have to distribute this out. 70 times 65. 70 times 65. What would that be? 4550. Okay. 4550. I'm foiling here. Plus 65 plus 70A makes 135A plus A squared. And then I'm going to multiply everything by 3.5. I'm going to do that with my calculator, but I'm going to have to pause you to finish that. So hold on one sec. All right, so I found those two numbers. They're right there, 15925 and 472.5. So that gives me my right-hand edge over here. So it's going to be equal to 15925. 15925 plus 472.5. 472.5A plus 3.5A squared. So that's the left hand, or the right hand side. Over here on the left hand side, I'm going to combine like terms. Find out what 10660 plus 8470 equals, and the other two. One sec. There we go. From my calculator, I get 19130 and 285. So that goes over here. Now this is a quadratic. See it right there? And the way to solve a quadratic that's this messy is to get it all on one side set equal to 0. So one sec. There we go. So I subtract 19130 and 285A from both sides, combine like terms over here, and rearrange it. You get 3.5A squared plus 187.5A minus 3205. And that, my friends, is a quadratic. So A is equal to, and then we'll have to use the quadratic formula. All right, so there it is. Poof. Negative b, that's negative 187.5, plus or minus the square root, there's b squared, 187.5 squared, minus 4 times a, which is 3.5, times c, all over 2a. Now I'm going to use my calculator to figure out this part right here, and the bottom I can tell is 7. So one sec. There we have it. It's 80026.25 under there. So now I'm going to make the calculator find that number. Alpha F1, hit number 1, negative 187 plus the square root of 80026.25. Then I'm going to arrow down and hit 7, enter. And there we get 13.69, just like when we did with the calculator.